This is momentum 3. The goal of momentum 3 is to be able to find the velocity of an object in a collision or explosion. This might be the initial velocity or it could be the final velocity. In this example problem, we're looking at a bullet that's fired, and the bullet has some known mass and it has some known speed when it comes out of the barrel. It's heading directly for this block that has a mass of 0.5 kilograms. That's before the collision. Then the bullet hits the wood and it gets lodged inside of the wood. And I want to figure out this velocity. I'll call it v. What's the final velocity? And this would be the final velocity of the bullet and block together moving off in that direction. To do this, we need another if chart. We need an if chart. These are so freaking powerful. Okay, let's start off with our I side, and then we'll draw our F side. Okay, let's, I don't know. Let's keep this not orange. Let's keep red. Okay, here's my I, here's my F. The I side corresponds with the initial case, and the F side corresponds with the final case, before the collision and after the collision. Well, before the collision, I have two objects, so I need to make sure that I have two bars on my I side. I've got the bullet, which is super small, 0.02 kilograms. That is tiny. I'll call that 0.002 kilograms. And I also have the block, which is 0.5 kilograms. Not huge, but very big compared to the size of the bullet. So I'm going to make it look like this and write 0.5 kilograms. Okay, next step, hopefully you guessed it, we need to label orientation. We need to label a forward and we need to label a backward. Then we need to pick out our velocities. Well, let's start with the block. This is easy. The block is still, it's not moving. The bullet's heading this way, but before the collision, the block is not moving. So to represent that, we're going to write or draw this straight line on the 0 axis because this is 0 meters per second. Which means that the momentum there must be 0. 0.5 for mass times 0, 0. So the total momentum of the block is 0 kilogram meter per second. Okay, that makes sense. What about the bullet? Well, it's moving at 600 meters per second up here, and I can draw this bar. Something like that. Let's color this in. The bullet is moving forward, so I drew it going up as compared to down. And let's find the area in there. Why don't we? The mass, 0.002 times the velocity, 600, is 1.2 kilogram meter per second. This is the area in this rectangle. I'm doing length times width to get this area. So the total initial momentum, must be this momentum plus that momentum. 1.2 plus 0 gives me 1.2 kilogram meter per second. Cool. Remember back to last video for momentum 4 when I said that the total initial momentum equals the total final momentum? That's going to be super important for us in this problem. Total initial momentum equals total final momentum. If you don't have that down somewhere, you should probably get it down. If you're still confused after you get it down, you should probably get a tattoo of it somewhere on your body so that you can remember it forever. Total initial momentum is equal to total final momentum. Okay, now we're considering the final case. Well, I have a bullet that is lodged inside of a block. Both of these are objects together, so I could consider them one object. And that's what I'll do. I'll say that this object here is both the block and the bullet, and the mass of that must be, well, total mass that is, must be the mass of the block, which is 0.5 kilograms, plus the mass of the bullet, 0.002 kilograms. And when I add those two up, I get 0.502 kilograms. And I know it's moving forward, I just don't know what velocity it's moving with. It must be slower than the bullet, but I don't know what it is, so I'm going to do this. Pick out a point there, call this V. Just like I did in orange, I should do this in orange. This is the velocity that I'm trying to solve for, and I'm labeling it on my final chart on the velocity part of the graph. Remember, this is for velocity, this is for mass, and I'm going to draw my block. I know this side, I don't know this side, so how could I figure out this area? Well, this is where I use the total initial momentum, which is the total final momentum. I found the initial momentum. Look at that. So this must also be the total final momentum. So the area of this box is 1.2 kilogram meter per second. Now look at this. I know this side, I don't know this side, but I know the area inside. So I could write out this expression that length times width is equal to area. I know 0.502 times b is equal to 1.2. And I could solve for v that way by dividing both sides by 0.502. Or I could think about this in terms of momentum and think, well, I know that momentum is mass times velocity. I know that my total momentum is 1.2. I know that the mass is 0.502, and I'm trying to solve for this velocity v. Both of them yield the same equation. Now the final part is just solving for that equation, right? So here we are. Let's solve for this. I have 1.2 is equal to 0.502 v. Well, if I want to get v by itself, I'm going to need to divide by whatever it's attached to. In this case, it's multiplied by 0.502, so I'm going to divide by 0.502 so I can cross both of these out. And look at this. 1.2 divided by 0.502 gives me the answer of 2.4 meters per second. What does this mean? This is the velocity of the block plus bullet together, because they're lodged, the bullet is lodged inside the block after the collision. That is momentum 3. Finding the velocity of an object in a collision or explosion using some givens and solving for an unknown. Okay, that's all for now.